Yes, I send it to everybody.
Okay, I'll send you
That's how I do it. Sometimes. I'm
I
supposed to throw
am
this in
still
the garbage.
planning girls my cutting, and I am planning to have 4 tables.
All right, let's go
Extra.
ahead and start this.
Proud for you. Oh, I get my table. No, I'm just kidding. Did I get my table by myself?
Yeah.
So silly.
So I am clear on 4 tables, you guys.
This is the third exam final review, and it covers chapters 6, 7, and 8. So basically solutions and pH problems.
With my gift, and I'm like, here you go.
Let's start off with this guy.
Put a tear. No, that's
We have 0.3 liters of a 1 molar solution of calcium nitrate. So what do we have in this solution? When you look at a problem like this, first thing you should say is we have a concentration and a volume. And remember, concentration times volume is moles.
Are you recording this too?
Yeah. Concentration times volume is moles. So we have 1 times 0.3. That means we have 0.3 moles of calcium nitrate. Okay, so you could do that in your head. So let's look at our answers here. Our first one, well, by gosh, is 0.3 moles of calcium nitrate. That's good. Right?
Yep.
Now, the next one is 0.3 moles of calcium cations. If you look at the formula for calcium nitrate, every calcium nitrate has 1 calcium. So if we have 0.3 moles of this, we also have 0.3 moles of calcium cations. 0.6 moles of nitrate. Well, every calcium nitrate has 2 nitrates, doesn't it? So if we have 0.3 moles of this, we have 0.6 moles of the anion. A, B, and C are all correct. Any questions?
So you did 1 times 3 point, that 0.30?
Right, concentration times volume. So 1 molar, that's our concentration. 0.3 liters is our volume, and that's moles.
And that's how you got that one. Well, what is that 164.1? That's the moles, right?
That's, yeah, no, that's the molar mass.
Okay. Gotta ask everything.
All right, here we're taking potassium chloride and reacting it with silver nitrate. When we do that, we get silver chloride and potassium nitrate. It's a double replacement reaction. Okay? According to the reaction shown below, here we have 0.5 moles of potassium chloride, 0.5 moles of silver nitrate. So that's enough to do it, isn't it? They're equal quantities. All right. What are our answers? Theoretical yield is 0.5 moles. Now, if we have 0.5 moles of each of them, how much product do you get? 0.5 moles. So this looks good. Our second choice here, 143 grams of silver chloride. Well, up here it says silver chloride has a molar mass of 143 grams. So 143 grams is 1 mole, not half a mole. So that's wrong. 1 mole of product will be formed? No, we just made the argument. It's going to be half a mole. Potassium nitrate will precipitate? No way. If you even look at the equation, silver chloride's a solid, and this stays in aqueous solution. So the only one here that works is the theoretical yield is half a mole. And once again, we have half a mole of this, half a mole of that. We get half a mole of these guys. Any questions? All right, here we have a 1 molar nitric acid solution, 1 mole per liter. And we have half a liter of it. How much water do we have to add to this to make the final concentration 0.5 molar? Now what I'm going to say here is once again we have a concentration and a volume, don't we?
Mm-hmm.
So we know how many moles we have of nitric acid. We want our final concentration to be 0.5 moles per liter. So, if we simply multiply our concentration and our volume, we have half a mole. Now, we want half a mole per liter. We've already got 500 milliliters of it, don't we? So how much more do we have to add? Well, we have to make this 1 full liter, don't we? Our half a mole in 1 liter. So we simply have to add 0.5 liters. Any questions? Concentration times volume gave us moles. We want 0.5 moles per liter. Starting off with half a liter, so we simply have to add another half. Very simple calculation. Here we have 0.375 moles of something, and our total volume is 1340 milliliters. What is this concentration? Well, by concentration, of course, we mean moles per liter. So, all we have to do here is take the number of moles, divide by the number of liters. We have 0.375 moles. 1340 mils is the same as 1.34 liters. Do our simple math. And this is 2.8 molar.
Why are you dividing now instead of multiplying?
Well, the definition of concentration, remember the definition, is moles per liter. Moles per liter is concentration.
So let's divide
All right, here we have an abstract sort of reaction. It takes 2 A's, 2 B's, and 6 C's to make 4 D's and 3 E's. Okay? Now, I tell you that you have 2 moles of A. We have 3 moles of B and 6 moles of C. What are we going to get? Well, this equation, we need 2 A's, 2 B's, and 6 C's. We actually have 3 B's, don't we? But we have extra B. We don't have to worry about that. B is in excess. So that's good. We also have 2 A's and 6 C's. So these are good, and we have extra B. So what's going to happen? If we have enough of everything here, we're going to get 4 D's, aren't we? So that's this guy. B says only 2 moles of D will be formed. Well, that's not right, is it? Because we just said it's 4. C, 3 moles of E. Well, if we have these guys, we will get 3 E's. So that's right. That means that the best answer here is A and C. We have excess B, we have just enough A and C. Any questions?
It looks like you're just basically looking at the numbers.
That's right. It looks
Coefficients.
really complicated, but it's really simple, isn't it? You have 3 B's, you only need 2, and we have 2 and 6. So we're good.
Yeah, this
All right, here we have 200 mils of 1 molar sodium hydroxide, and we're going to dilute it to 10 liters. So we add water to it. We want to know how many moles it's going to contain. All right, well, first of all, we need to figure out how many moles we have to start with, don't we? How do we do that? Concentration times volume. Make sure your volume is always in liters. So we have 0.2 moles that we're working with. Now, if we take our 0.2 moles and we dump it into 10 liters, how many moles do we have? We're not talking concentration here, we're talking moles. The number of moles doesn't change, does it? We could dump this into a bathtub. It would still only be 0.2 moles. We have 0.2 moles regardless the volume that we dump it into. Any questions?
Is it going to be simple like this when we take this quiz?
Of course the exam is simple.
Dr. Young, can
Look at it.
you explain that again? Like why it'll stay moles?
Well, you have, let's say that we have a bucket, 2 buckets. One with a gallon of water in it, one with 10 gallons of water in it, okay? You drop a nickel in one. How many nickels are in it? 1. If we put the nickel in the other one, how many nickels are there? 1. The number of moles doesn't change. Just the volume. Now the concentration will change, but that wasn't the question. It was just the number of moles. All right, a pH problem. We have a solution that has a pH of 5, and we're raising it to 7. What happens to hydronium ion concentration? It increase by a factor of 2, by a factor of 100, decrease by 2, decrease by 100. This one, of course, is silly. Well, remember, the lower the pH, the stronger the acid. Right? So we are going from a stronger acid to a weaker acid. Every pH unit is a power of 10, isn't it? So we have 2 powers of 10, and that's 100. pH increases, hydronium decreases. It's a log scale, so 2 pH units is a factor of 100. The lower the pH, the more hydronium. So we're at 5, we're going to 7. Hydronium ion is decreasing. That's 2 log units. Each log unit is a factor of 10, and that makes 100.
So, but, okay, so just say if it was by 2. I mean, what's the difference of it decreasing by 2 and by 100? I know you just said with the hydronium, but if it was to decrease by 2.
Well, this would be 10 to the minus 5 molar, right? If we decreased by 5, it would be 0.5 times 10 to the minus 5. This is 1 times 10 to the minus 7. Big difference. All right, we have sodium nitrate. We are decomposing it to make sodium nitrite, and oxygen is getting off. We are given here that we have 0.475 moles of sodium nitrite. And the question is, how many moles of oxygen are we going to get? All right, let's look at our equation here. Look at the stoichiometry. It takes 2 sodium nitrates to make 1 oxygen, doesn't it? 2 of them. So if we had 2 moles of sodium nitrate, we would get 1 mole of oxygen. But we don't have 2 moles. All we have is 0.475. You get half as many moles of oxygen as you have sodium nitrates. Half as many. Right?
Instead of heavy, I'll bring it.
So if we have 0.475, half of that is 0.2375. Half as many moles.
You did half of 4, 7.
Yeah, that's half of it. Divided by 2. Two moles here, 1 mole there, divided by 2. That's all you have to think about.
Now, did you do it because it's showing like on both sides of the, like the reactant and?
Well, it's a balanced equation, so we don't have to balance it. We just simply look at our coefficients, 2 to 1.
Okay.
2 to 1, that's it. Another equation here. We did this in lab. We took sodium hydrogen carbonate, heated it up. We got sodium carbonate, CO2, and water. Here we want to know the percent yield. All right, so in order to do percent yield, remember, we have to look at our actual yield and the theoretical yield. The actual yield is given here. We have 0.25 moles. That's the actual yield. We have half a mole of sodium hydrogen carbonate. Now, according to our equation, every 2 sodium hydrogen carbonates gives 1 CO2. So again, it's a 2 to 1, isn't it? So if we had 2 moles of sodium hydrogen carbonate, we would get 1 mole of CO2. But we don't have 2 moles. We only have 0.5. So our theoretical yield is going to be half as much as we have of our sodium carbonate. We have 0.5 moles, half of that is 0.25. So that's our theoretical yield. Now, how much did we really get? Oh, by gosh, this was perfect. Somebody got 0.25 moles. That's exact. That means this was 100% yield. All right, we have a 1 molar sucrose solution. We want to know how many moles of sucrose we need to make 500 mils of a 1 molar solution. All right, if we wanted a 1 molar solution, we would have to take 342 grams, that's 1 mole, and dissolve it in a liter, right? But here, we only want half a liter. So instead of 342, we need half of that. We need half a mole. Half a mole in half a liter is still 1 molar. Any questions? All right, we have a 2.3 molar solution, and we have 770 mils. How many moles of solute, that is, whatever this is, how many moles of it are in this solution? Now, everybody should instantly be saying to themselves, we have concentration and volume. That gives us moles, doesn't it? Concentration times volume gives us moles. Our concentration here is 2.3. Our volume, remember it must be in liters, is 0.7 liters. Simply multiply these together. The liters will cancel. We're left only with moles. And it's 1.8. Concentration times volume in liters. Make sure it's liters. Don't let me get you on that one. Make sure the volume is always in liters. All right, I love this question. So you will see one exactly like it, okay? Make sure you know how to do this. We are given a hydroxide concentration. We must calculate a hydronium ion concentration. How do we do that? On our 3x5 card, we have written down hydronium times hydroxide is always 10 to the minus 14 molar. Always. All right, well here we have hydroxide. So let's just substitute. So to get hydronium, what do? We take 10 to the minus 14, divided by 10 to the minus 5. Now make sure that you know your calculator and it knows you. Remember, we are dividing here. When we divide, you subtract exponents. So this is going to be 14 minus a minus 5. And 14 plus 5 minus 14 plus 5 is 10 to the minus 9. Any questions? You see, you were all so worried about this exam. It's going to be so simple, isn't it?
Okay, sure. I think so.
Going to be really simple.
Maybe don't tomorrow's because I'm probably gonna do more brain.
All right, which of these is an acidic solution? Which of these is acidic? The pOH is less than 7. Now remember, pOH plus pH is always 14, isn't it? So let's pretend that our pOH here was 5. If our pH was 5, I'm sorry, pOH was 5, what would pH be? 9. Is that acidic or is it neutral? Or basic? Yeah, it's basic. pH is above 7, it's basic. Our second choice here. Hydronium times hydroxide is less than or equal to 10 to the minus 14. Well, no, it's not. It's always exactly equal to 10 to the minus 14 at 25 degrees. If you heat it up, it changes. But 25 degrees,
Hold it.
10 to the minus 14. Always equal to that. Hydroxide is less than hydronium. Now, hydronium is the acid part, right? Hydroxide is basic. If we have more hydronium than we do hydroxide, that means the solution is acidic. If you have more hydronium than you do hydroxide, it must be acidic. Any questions?
You said it's if sodium hydrogen.
Hmm?
If hydrogen is less than what?
You're going to make me do this again. If hydroxide, that's the basic part.
Okay.
If it's less than hydronium, then it's acidic. If there's more hydroxide, it's basic. If there's less, it's acidic. If they're exactly equal, it's neutral. Conjugate acid-base pairs. Now this is an equilibrium. Remember, that means the reaction goes both directions, right? Here, this question specifically talks about the reverse reaction. So we're going from these guys back to here. So what we're looking for here is the acid component on this side of the equation. Question you ask yourself: what reactant on this side donates the proton? What reactant donates the proton? Well, my gosh, sulfate doesn't even have a proton, does it? This is carbonic acid. It's going to donate a proton to sulfate to make hydrogen sulfate. So this is our acid. Now the next question you ask, because you're looking for a conjugate acid base, is what's formed after it donates its proton? What is formed afterwards? Well, once this guy loses one proton, what does it form? Hydrogen carbonate. So our acid-base pair from the list here, our acid is going to be carbonic acid. Our conjugate base is going to be hydrogen carbonate. Any questions? All right, here's another reaction. Here we're taking this stuff, it's an organic compound called acetaldehyde. Acetaldehyde is found in apples, little green apples. Kind of a apple flavor sort of stuff. Reacts with oxygen, that means it burns. When you burn acetaldehyde, you make CO2 and water. Our equation is balanced. We're looking for how many moles of CO2, that's this guy. If we take 44 grams of acetaldehyde. Now, we're asking for moles here, aren't we? So, first of all, we have to figure out how many moles 44 grams represents of acetaldehyde. Well, by gosh, the molar mass here is 44.05, so that's 1 mole. That's 1 mole. So let's look at our equation here now. 2 acetaldehydes gives 4 CO2s. You're given 44 grams of acetaldehyde, and that's exactly 1 mole. For every acetaldehyde, you get 2 CO2s. 2 gives 4, 1 would give 2. Any questions? All right, here's our standard conjugate acid-base question. Which is correct regarding a conjugate acid-base pair? The base will have 1 less proton and 1 more negative charge. Remember, when you transfer a proton, the proton's positive, isn't it? So this compound, whatever it is losing a positive charge. That means that typically makes it negative. So this one looks good. We lost the proton, gained a negative charge. The acid will have 1 more proton. That's true, it does. The acid has 1 more proton. But 1 more negative charge? No. It would actually have 1 more positive charge. Because remember, the proton is positive. Formed by reaction with hydronium, that's silly, or hydroxide, that's silly. This is obviously not correct. Acid loses 1 hydrogen and 1 positive charge to form the base. 1 less proton, 1 more negative charge. was asked a little bit earlier about trick questions. Closest thing to a trick question is this next one. And I like this question. We have 1 liter of a solution. Hydroxide is 10 to the minus 7 molar. We're going to add 1 liter of a solution that has hydronium at 10 to the minus 7 molar. Which of these is correct? Hydronium will be 10 to the minus 7 and the solution is neutral. Hydroxide is 10 to the minus 7 and the solution is basic. Hydroxide times hydronium will be 10 to the minus 12. Right away we know that's wrong. And because C is wrong, actually D and E are also wrong. So it's got to be one of these two, doesn't it? Now think about it. We have a solution. Hydroxide is 10 to the minus 7 molar. What aqueous solution has hydroxide at 10 to the minus 7 molar? Neutral water. Plain neutral water. So we're taking water, we're adding more water, we still have 10 to the minus 7 molar hydroxide and hydronium because it's neutral water. So the best answer here, clearly it's not basic, it must be neutral, and the hydronium will be 10 to the minus 7 molar. So will the hydroxide. Closest thing to a trick question. All right, this one isn't a trick question. It's a little tricky. We have a 2 molar solution of something. We want to prepare 1 liter of 0.5 molar. So what we're going to do is take our 2 molar solution and dilute it. If we look here, in our final solution, we're going to have 1 liter of 0.5 molar. That's a concentration and a volume, isn't it? What does that give us? Moles. So, in our final solution here, how many moles of this stuff will we have? 1 times 0.5, or 0.5 moles. Now we want 1 liter of a 0.5 molar solution. Now remember, a molar solution simply means moles per liter, right? This is molar. So we know how many moles we have, that's 0.5. We know, well, let's solve this for liters. That's what we're looking for, is the volume. So let's go ahead and just rearrange it. So we have 0.5 moles. Our starting solution here is 2 molar. So 0.5 moles, 2 molar. How much do you need? 0.5 divided by 2, 0.25 liters, which of course is the same as 250 mils. Now, once again, let's go through the steps. Concentration times volume gave us moles. We know that moles divided by concentration gives us liters. Our solution here is 2 molar. We have 0.5 moles. Simply divide them 0.25 liters. So a little tricky. A little tricky. You have to think about that one just a little bit. This is the other question that I really like. And again, you will see this on the exam, I promise. I promise. We're going to be given a pH. We have to calculate POH, hydronium, and hydroxide. Okay? Now on the tutorial, you've all done this 100 times. At least 25 times. All right. What do we know about pH and POH? pH plus POH is always 14. Right? How do we calculate hydronium? Hydronium is simply going to be 10 to the minus pH. And we all know how to do that on a calculator by now. How do we calculate hydroxide? We could do it 2 ways. We could take 10 to the minus 14 and divide by hydronium. Or we could simply take POH and do 10 to the minus POH. That's even simpler. So here's what we're doing. POH is simply going to be 14 minus our pH value. You can almost do that in your head. And that's 11.74. Secondly, 10 to the minus pH. Here you need your calculator. You do 10 to the x, type in minus. Remember, it's a minus pH, minus 2.26. And that's 5.5 times 10 to the minus 3. Remember, it's minus pH. Finally, OH, we're going to do it the same way. Going to hit 10 to the x on your calculator. Type in the POH value here, so minus 11.74. And you should get 1.8 times 10 to the minus 12. Make sure you bring your calculator. Make sure you know how to do these very simple logarithms or 10 to the x calculations. Make sure I don't have calculators to loan you. Phones sometimes work, sometimes they don't. And our last one here. We have 1 liter of 0.5 molar sodium hydroxide. To this, we're going to add 1 liter of 0.5 molar HCl. Now, what happens when a strong acid and a strong base mix? We form a salt in neutral water. If they're exactly equal, all you're left with is the salt and water. So this is the same. Those two are going to neutralize. It's a neutralization reaction. So we know it's got to be neutral. We know we're going to make water and sodium chloride. All right, so let's look at our options here. Solution's neutral. Yes, we just said that. My gosh. It's going to be neutral. Equal amount of acid and base is neutral. Solution will be basic. Well, it can't be both, so B's got to be wrong. concentration of sodium chloride will be 0.25 molar. Well, let's think about that one, okay? We have half a mole of sodium and half a mole of chloride, don't we? But we now have 2 liters. So that's twice as much volume. Half a mole in 2 liters. The volume has doubled, so the concentration is cut in half. That means that this is correct, and that the best answer is A and C. Now, number 1, that was easy, didn't take us long at all. You had to listen to me the whole time. Number 2, remember, we have 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 times 5 is 45 points on tutorials that you can get that will add directly to your exam score. Plus, hand in your sample exam, make sure your name's on it, and you get 5 more.
Dr. Young, can you show me how to do the lobbyists for the calculator again?
Okay, well, I need to see your calculator. All right, any questions?
No.
All right, guys, we're
Okay.
done.
Okay, so we have lab on Monday, not the test.
Right, we have lab Monday, we have the test on Wednesday.
I got a week.
to print it out. Just wrote it down.
Okay.
Girl, you should have told me. You could have had this extra when I had.
Of course,
I'm sure we're getting out of this. You want to transfer your answers on here? You can keep them for your studies.
No, I was taking notes.
Oh.
All right, so let's see how to use a CI. Okay, as I remember, first thing we have to do is turn it on.
What do we get next week?
Okay?
Okay.
Yeah, just, I'll stick it there. Thank you. All right, so for a CI 84, you need to use the 10 to the x and the log. It was just 10 to the x is in blue, so you're gonna hit second, and then 10 to the x.
Okay.
And then all you do is type the number in here.
So that would be that,
That would be minus 2.26. So minus, that's sign,
this is
5.5.
I'm ready to play your phone.
Isn't that simple?
But how do you write it like,
I'm ready.
how did you write it like that? Does it come up like that?
You can make it come up like that.
If you don't do the second, and you just do like log?
I can't force one. Let's see.
Maybe you can do it on hers. It's easier to do it on hers.
No, you can put over here to scientific.
Oh, okay.
I have it, right?
Yeah, hers is probably better, Dr. Young.
Yeah. It's an 83, this
Let's
is
see.
84.
So, oh, that's the one you just did. So 10.
Yours is more complicated.
No, no, no,
Oh.
no, 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 no. 10 to the x minus 2.26.
Oh, there it goes. Okay. Okay, so it would be 5.5 because you round up, and then times 10 to the third.
Yep, minus 3.
Okay. I'm gonna try that. So
I'll
you
try it
went-
with this one. Type in 10 to the minus 11.74
So you went second, log 10
minus
minus
11.74. How about that? Gosh!
Okay, let me turn in my extra credit too. Thank you, Dr. Young. Oh my gosh.
If
I
I
do this.
If I do good on these chapters, I will make a party about.
I'm having a
Marie?
hard time. Oh, because I'm still waiting for my food, Marie.
Oh no, I told you you come to my house.
Also, you
Always
gotta let me
cook.
know. You gotta. I don't want to
I
just.
always cook at my place.
I see all the time.
I
Like,
always cook too.
Yeah.
You
I
do
always
too,
cook.
Dr. Young. Invite me over. I'm gonna come.
I have to
I
run
cook
home.
a lot of different dishes, Dr.